Okay, so we're going to look at some complex analysis, and what we're going to do is we're going to integrate this function here, sine of z minus pi over 2 divided by z cubed with respect to z, and it's over the region R. Now the region R is defined as the modulus of z minus I equals 2. So that is just going to be a circle centred at the point I. So let's just draw that up on the graph. So that's the point I, that's the reals, that's the imaginaries. Let that be the point 3i, and then this will be minus I. So now let's just draw. Okay, it's nearly round. Okay, that's a start. Okay, so we've got here a function on the top, sine of z minus pi over 2, and a polynomial on the bottom, z cubed. Now this is looking like we're going to use Cauchys' nth derivative formula. So for Cauchys' nth derivative formula, we'll need to rewrite this integral in terms of the numerator and denominator. So if we let g of z equal sine z minus pi over 2. Now this function in the numerator, we can see is analytic everywhere on the complex plane. So this is analytic on complex plane. And we can also see that this here, namely this, is a simple closed contour on the complex plane. So it's closed as in it's as a border, which is the modulus of 2, and it's connected in the complex plane. So with that in mind, and we've got this here that is analytic on the complex plane, we just need to now find where the singularities are. So the singularities of z cubed is just going to be at 0. So singularities at z equals 0. Now this one here, because it's cubed, that's going to be a pole of order 3. So pole of order 3. Now that's important now, because this 3 here will tell us how we're going to use the derivative formula. So basically what we do now is we take the second derivative of this function g of z. So basically, as we have this number here 3, we take the second derivative. So g prime of z. So let's take the derivative of z minus pi over 2. Well, pi over 2 is a constant, so we just need to take the derivative of sine, which is cosine. And then the input stays the same. And with the chain rule, the z just stays as z. Take the derivative again. So now we take the second derivative of z. Let's make this z look nice and clear. Equal negative sine z minus pi over 2. So that's our second derivative. Okay, now next thing we need here is this singularity. So the singularity is at z equals 0. So now what we do is we say on the region R, g of z over z cubed dz equals, so now what we do, we follow this formula to calculate the answer. It's 2 pi I divided by 2 factorial. So basically it's 3 minus 1. So if I just write that as 3 minus 1 and then write factorial, and then we multiply by the second derivative at 0. And that is going to give us our answer, basically. So there's no integration at all. All we do is just take the derivative of this numerator twice, calculate it into this formula, and that takes care of the answer. So let's work out what this one is at 0. So g2 of 0 equals negative sine of 0 minus pi over 2. Well, the sine of minus pi over 2 is minus 1. So basically we've got minus minus 1, so that equals plus 1. So that's our there. 2 factorial is 2. So this and this will cancel out. So basically all we're left with now is pi I times 1, which just equals pi I. And that is the answer to our integral. Sine of z minus pi over 2 divided by z cubed with respect to z over the contour r, z minus I equals 2. The answer is pi I. Okay.